Okay. Well, let's see if it's working on. I don't know if this is gonna work.
Are you trying the desktop broadcast?
Yeah, I'm using. Let me see if it's working. Well, we're on YouTube Live.
Okay.
Hi, everybody. Welcome to the weirdest show and tell.
Hi.
Hangouts is down, but we're not.
We're not.
So we're still going to continue the show and tell. The show and tell must go on.
Yes.
All
We
right.
fight for the users.
Yeah. So this is just our team here at Adafruit. If we need to do this again other weeks, I think I can take the peer in stuff and then broadcast it through YouTube Live. So Tony, show your project.
Hey, yeah. So what I was going to just talk about was a new little video project series that I was starting to do the smart holiday lights. So you have something like this, a little holiday wreath. Well, it's weird. It makes an interesting noise when I shake it. So you have a holiday wreath, and then you have something like this, a bunch of NeoPixels. And so I want to combine these and decorate the wreath with NeoPixels, or it could be a little Christmas tree, it could be like around your windows, it could be a menorah, do any holiday with this. And the cool thing is with the addressable RGB LEDs, you can light them up any color. So if you want to do red and green for like traditional Christmas, you can do that. If you want to do like blue and white for Hanukkah, you could do that.
Testing.
Or the Kwanzaa
Hello,
colors.
testing.
I think Kwanzaa is red, green and black. Is it correct? I can't remember. Sorry if I got that wrong. But whatever holiday. So if you want to do it for Easter or something in the future, it's it's all NeoPixel.
You never have to take this wreath down.
Yeah, there you go. Exactly. Yeah, just decorate once. I'm all about efficiency. So
Yes.
yeah. So that's the idea. But the big twist is because everyone's done holiday lights, of course. But I want to use MicroPython to power these. So I was using actually the video I did yesterday on Tuesday. I was just using a little ESP8266 feather, and this is the NeoPixel feather wing on top of it. So just tiny little test prototyping platform. But if I can light up this little NeoPixel feather wing, then I can light up, a whole reel of NeoPixels. The code's going to be exactly the same, just number of pixels changes. So the last video stream I did was just kind of testing animation, converting Arduino animation code into MicroPython animation code, which is a lot simpler. It's a little bit easier to see kind of how the algorithm works for it. So like just having the lights kind of move around and chase each other, or just pulse on and off with different colors, or the effects that I did. So that's what I started with, and the reason I'm using the ESP8266 is because I want to use the Wi-Fi capabilities of it to do smart holiday lights. So it's got to have phone control, or something that I can open up a web page, tap a button, and start changing the colors of the lights with it. So that's what I'm going to start exploring. Probably Friday I'll have a new video out. So I did part one yesterday on Tuesday. Go to youtube.com/Adafruit. You can see that video where I was just prototyping and just, like I said, converting Arduino NeoPixel animation code into MicroPython and running it. And then part two I'll do this week, where hopefully I'll get more to, I'm going to play with how to save state onto the MicroPython board, which is really cool because you've got a JSON parser, and you can just take all your state, serialize it as JSON, save it onto the file system on the disk or on the MicroPython board, load it back up. So I'm really curious to explore that and see how that's going to work. And then also come back and add the smart control, so control over a web page, maybe using like the WebSocket server that they have built into the ESP8266 MicroPython port. So look forward to smart holidays with me in the next few weeks.
The smartest holiday. Oh,
So
the
that's
smart
all that
holiday.
I had. I know. Let's see. What are you guys up to at the Adafruit Factory?
Well, we have we can do Noah and Phil B, where this is a new world of appear in broadcasting via Wirecast. Yee. So let's try to make this work. Noah, what do you want to show?
Hey guys, is the audio working?
Yeah, we can hear you.
Okay, sorry about earlier. I disconnected my mic and I forgot. I wasn't sure what was gonna happen, but hey, here we are. Yeah, so this week's project actually already went up. It's a little mini Commodore PET. It's like a mini replica, and it's a little 3D printed case. And inside of it is the Adafruit M0 feather with the 16:9 LED matrix. I didn't even turn it on. Ah. Also has a battery, so it's portable, and it's a kind of a cute little desktop toy. But it kind of gave me a little kind of like a little history lesson, because I didn't really know much about the Commodore PET, so I looked it up on Wiki. By the way, Wiki, you guys should donate if you haven't already. So it was a computer that came out in the 70s, and it was kind of a big deal because, well, in the late 70s, because sort of before this, computers weren't really like this whole unit. It was like just the keyboard and the computer, and you'd have to kind of get your own monitor. So this one sold pretty well. So I got inspired by that, and of course by Tony, because he's doing a lot of MicroPython stuff. I was like, hey, I need to do a project with the CharliePlex LED matrix. So Phil B also did a project previously with this guy. It was a flame pendant, and I was like, I want to do something a little bit different. So instead of wearing it, I thought I'd put it on my desk. So here it is. Just like 10 parts. It's like a dollar to 3D print. Yeah. The code actually is running, is written by Phil B, of course, and he can talk about, if that's what you're going to show off, Phil B. That's really it. That's all I got. This cool little box. That's it.
It's cute though.
By the
Look
way,
at this
this
project.
is all surprisingly working well. I think I might just switch to this.
Really?
Yeah,
Okay. Yeah, I mean, the frame looks pretty smooth. The audio's coming out good, so
Yeah, it's weird. Okay.
it's in my hand.
Okay.
All right. Next up, Phil B. What do you want to show?
Oh, yeah, actually, Noe suggested I should talk about the code a little bit. I'm not sure what to say. Actually, this is kind of derived. He mentioned the flame pendant that we had done before, and the animation code kind of derived from that. Normally, you'd use the Adafruit GFX library, and that's cool because that gives you, lines and text and lots of graphics primitives. But if you want to get like really buttery animation, you kind of have to dig into the data sheet and do some more direct things with the CharliePlex hardware. So that's what I'm doing in this project. I tried to explain what's going on in the code, so it's not just totally WTF. But I hope that's instructive for people who are looking to do smoother, not flickery animation on these little displays.
All right.
Cool.
Thank you for rapidly coming up with a project to show and share.
Did you use the 8 buffers, or did you just?
I'm only using 2 of them.
Yeah, but
You show one while you draw on the other, and then you flip the 2. Now you're showing this one and drawing in that one, and you just flip back and forth like that, and then you don't see the flicker of the display being rendered.
Yeah.
Pretty simple effect, but again, you have to kind of get into the fiddling with the registers on the chip to access that.
Okay.
So
Cool.
datasheet is your friend.
All right.
All right. We just have like projects ready at all times.
Yeah. No, I've got like 6 projects. I'm like,
Yeah. And,
emergency.
And our smart guests have already figured out. So if you go to peer.in/Adafruit, you can knock to be let in, and we're broadcasting it. So
All right. Let's have
I think this
one
is
visitor.
Hello.
So unmute your mic and.
Show us
Hey,
your project.
Kirby.
Hey, Kirby, how's it going?
Good. So I was able to port that project, and I'm working on the guide to the High Zero now, a board which more people have. And then I like Hot Wheels, so I want to see how fast they're going. So I built little adapters for the track and 2 of the brake beam sensors that will time when the Hot Wheel car goes by. And on a feather that'll be mounted back here with the OLED display, it'll give you the speed of miles per hour, so you can see which car is faster. Then I made it tall enough so my bigger vehicles can make it through still.
Cool.
That's really cool. So you've made your own speed trap.
Yeah. So I ordered the parts tonight, so I'll have those and I can finish wiring it up. And that's all I got. But now it's getting full.
Yeah. All right. Well, we're gonna send you an as seen on the show and tell sticker. Just email support@adafruit.com. Look at this. This room is going crazy. All right. I'm just gonna keep doing this. Okay.
Okay. Everyone, can you mute your mics if
Yeah.
you're not?
There's no way to tell names. I think that's Andrew. Hey, Andrew. Maybe.
All right, well, we're going to send you an as seen on the show and tell
Yeah.
stickers. Email
How do I
support@adafruit.com.
stop people?
Yeah, you're just going crazy. All right.
There you
Okay.
go. Okay.
Okay, Andrew. Andrew, unmute your mic if that's you, Andrew. Can't tell. Person in the maroon shirt, glasses, beard.
Uh-oh, Maker Charades time.
Yeah, audio problems are expected. It's okay.
Nope. Okay. Person with black shirt. There's no way to. This is exciting. Where's there his names on this? Oh, hey. Hello, person with the Columbia black sweater.
Oh, yes. So Peter, yes.
Hey, Peter, how's it going? Yeah, there's no names.
There's no names. We don't know your name.
Yeah.
The guy with
I'm
the
Peter.
4-channel scope.
Maker 572.
Yeah,
Begin.
that's me. Okay, hey, that is very impromptu, and I'm somehow on the wrong camera that I have to hold in my hand. So
This
anyways,
is all types of wrong, but we're gonna make it right.
all right. So, all right. There we go. So what I wanted to show off really quickly is a demo that we made with the Adafruit TFT display. It's 60 frames per second using the 1-bitsy that I showed off quite a while ago on here. And we also made new versions of the Blackmagic probe, the JTAG debugger that doesn't need OpenOCD. There is the previous version. These are new prototype versions. And we will have that on the Kickstarter that we just launched yesterday. So you might be seeing this here. So if you want to support us. I hope you like what you see. It's like I will be working on some more demos using your LED displays and stuff like that. Yeah.
Okay, tweet at us with the link to the Kickstarter and we'll retweet it because I don't know how to get the text
I'm totally
here.
gonna
I
back
sent
your
you already
Kickstarter.
a tweet at you.
Okay, great.
Because I was thinking the Kickstarter will not work, or the show and tell will not work out. There you go.
Okay. Okay, well,
Buy this man's boards. They're beautiful.
we have one more minute. We're
Thank
going to
you.
get Andrew in, and then we're going to go do Ask an Engineer.
Okay.
So,
Okay.
right.
Thanks. Sorry about the.
That's fine.
all good. Look, we made it work.
All right, Mr. Bitsy. I'm going
right.
to call you Mr. Bitsy from now on.
All right. Fellow with the feather.
We can't hear you. No.
But that's not our fault.
Okay, do you want
Okay,
to do the audio?
it's a
Well,
feather.
They can't hear us.
It's a feather, and it's an echo. Oh, you're doing the echo.
Oh, the feather
you're
echo
doing the
thing.
echo project.
Okay.
Yeah, echo. Turn on the
Okay.
thing.
That's actually perfect because otherwise our
Yeah.
echo would also respond. Okay, so he's got some app. What's the app? The app is Wi-Fi. Okay, yeah, you connect to the Wi-Fi. And then you did the Wi-Fi config where you log into the ESP to set up the Wi-Fi. Okay, so it's like, ooh, better. Okay, good. Okay, ooh, thing switch, yeah. So Wi-Fi manager. So it's a thing switch. Okay, and now you're gonna switch something. That's cool. I'm glad people are trying out that Echo ESP project. There's a cat. And he's been morphed into a cat.
Okay, we got to go do Ask an Engineer. We got to go do it. This worked. It was just weird. All right, thanks everybody.
Thanks, cat.
We're here every week, no matter what.
Look, we're doing the best we can.
Thanks, guys.
Thank you.
It worked out great.
Yeah, this worked. Okay.
Yay! All right, everybody.
Okay. Bye bye.
Bye, Carmen.
See you later.
Box cat.
How do I?